Hi, my name is Venkanna Kota. Today I want to discuss the analysis of a rectifier. The first analysis is that DC voltage. DC voltage of a rectifier. Now I am doing the analysis for half-wave rectifier. So this is the output of half-wave rectifier 0 to pi. The output is present only positive portion. During the negative portion, the output is 0. So the output waveform of half-wave rectifier looking like this. 0 to pi, only the output signal is present. The magnitude of the signal is like Vm, and during the portion of pi to 2 pi, the output is 0. So we have to, first of all, we have to determine DC voltage or average voltage to the output of half-wave rectifier. The basic formula of DC or the average voltage, VDC or V average is equal to 1 by 2 pi integration 0 to 2 pi input signal Vm sin omega t d of omega t. So this is the basic equation for the determination of DC voltage. DC voltage. So here VDC or V average is equal 1 by 2 pi 1 by 2 pi and 0 to 2 pi. Here first we have to split 0 to 2 pi is split into two parts, 0 to pi and 0 to pi, pi to 2 pi. So here integration 0 to pi Vm. So the output is present during the 0 to pi Vm sin omega t d of omega t plus and pi to 2 pi pi to 2 pi pi to 2 pi, the output is 0. So 0 dot d omega t. So 0 dot d omega t, the total value becomes 0. So then like this, 1 by 2 pi, this portion was only present, integration 0 to pi Vm sin omega t d of omega t Vm taken out of the integral, then Vm by 2 pi integration 0 to pi sin omega t d of omega t. So integration of sine is equal to, what is the value? Integration of sine equal to minus cos. So here integration of sine is equal to minus cos. So that's why this is becomes like this, Vm by 2 pi integration of sine omega t minus cos omega t and limits 0 to pi. So here Vm by 2 pi, we have to apply the limits, minus cos pi omega minus cos 0. So this is the upper limit pi and lower limit pi. So here Vm by 2 pi, Vm by 2 pi minus cos omega. So cos of pi, that value becomes minus 1, minus of minus 1 and minus of cos 0, 1 minus 1. So minus 1 plus 1. So the value becomes Vm by 2 pi 1 plus 1. So that is equal to Vm by 2 pi into 2. 2 cancel, the value becomes Vm by pi. So here the average value, average voltage, or this is the output, average voltage or DC voltage of a rectifier is Vm by pi. Vm by pi. Now I want to discuss the DC current. So IDC. Already we know the value of VDC. VDC is equal to what is value? Vm by pi. And then we want IDC. IDC. So here IDC is equal to I is equal to Vm by RL. Vm by RL. So Vm is equal to what is the value? Vm is equal to so here Vm, that is here VDC. VDC it is not a Vm. VDC IDC is equal to VDC by RL. So VDC is equal to what is value? VDC is equal to Vm by pi into RL. So Vm by pi, that is equal to Vm by pi, that is equal to VDC value. So Vm by RL is equal to Im value. So this value is equal to Im by pi. So therefore IDC is equal to Im by pi. And we know the value VDC is equal to Vm by pi. So this is DC current. Next we have to determine the RMS value. Now I want to discuss the RMS voltage. RMS means root mean square voltage. The basic equation for root mean square equation is that Vrms is equal to square root of 1 by 2 pi integration 0 to 2 pi Vm sin omega t whole square d omega t. So this is the basic equation for RMS, root mean square voltage. Root mean square voltage. So we have to find out RMS voltage. So 1 by 2 pi integration 0 to pi. Already I have discussed that the output is present only during the 0 to pi only. Pi to 2 pi, the output is 0. So that's why we have to take integration from 0 to pi only. In the previous question I already discussed that what is that 0 to pi, the output is present, and during the pi to 2 pi, the output is 0. No need to take the integration from pi to 2 pi. Only in the half-wave rectifier. So 1 by 2 pi to 1 by 2 pi as it is last calling. Integration 0 to 2 pi. Place lo integration 0 to pi transit. So here Vm sin omega t whole square d omega t square root. Root means square root. So then splitting. This is splitting. Vm square is there. This can be written as Vm square and Vn square sin square. So what will happen here? Vm square is there. Vm square is taken out of the integration and out of the square root. So that's why Vm 1 by 2 pi integration 0 to pi sin square omega t d omega t square root can be written as like this. And the integration for the sin square, how to do the integration for the sin square? So which can be converted to cos value, then it is very easy. So in the place of sin square we have to place 1 minus cos 2 omega. In the place of sin square we have to substitute 1 minus cos 2 omega t by 2. Why? Because sin square is equal to 1 minus cos 2 omega t by 2. This value is substituted in the place of sin square omega t. Then 1 by 2. 1 by 2 half 2 is there. 2 into 2 here. This value becomes 4. This value becomes 4. Then splitting this integration. Splitting this integration, then what will happen? Integration 0 to pi Vm 1 by 4 pi integration 0 to pi 1 d omega t minus integration 0 to pi cos 2 omega t d omega t. So cos value, this value becomes 0. Why? Because cos pi is equal to 0, cos 0 is equal to 0. So total this value becomes 0. So that's why the total integration and total root. So here Vm, the above equation becomes 1 by 4 pi integration 0 to pi d omega t, that means 1. The above integration is only the value of omega. Then we have to apply the lower limit and upper limit pi minus 0. So the integration is looking like this. The integration for this value only. So this value becomes 0. So here the total is square root. pi, both are cancelled. So here Vm by square root of 1 by 4 is there, that becomes Vm by 2. Vm by 2. So therefore the RMS Vrms value is equal to Vm by 2. Vm by 2. So this is the RMS voltage. This is the RMS voltage. Already we have discussed that VDC is equal to Vm by pi and Vrms is equal to Vm by 2. This value is only for the half-wave rectifier. Half-wave rectifier. Now I want to determine the ripple factor. Ripple factor of a rectifier. The equation or formula for the ripple factor is equal Vrms by Vdc whole square minus 1 square root. This is the basic formula of ripple factor. Ripple factor formula is equal to basically ripple factor is defined as ripple factor is equal to Vrms by Vdc value. Vrms by Vdc value. But Vrms is written as Vrms square minus square root of Vrms square minus Vdc square by Vdc. So here this can be written as square root of Vrms by Vdc whole square minus 1. When we have to take the common in the numerator Vdc, then Vdc out of the which can be taken out of the square root, then Vdc by Vdc cancel, then the value is the value like this. Ripple factor is equal to square root of Vrms by Vdc whole square minus 1. So we have to apply the values. We have to apply the values of Vrms. Vrms value is equal to Vm by 2. Here Vrms is equal to Vm by 2 and Vdc is equal to Vm by pi. We have to apply these two values in the above equation. Then what will happen? Ripple factor is equal to square root of Vrms, and in the place of Vrms we have to substitute Vm by 2. Vm by 2 by, in the place of Vdc we have to substitute Vm by pi whole square minus 1. So then the value becomes pi by 2 whole square. So RMS value is equal to square root of pi by 2 whole square minus 1. After calculating this value pi by 2 whole square minus 1 square root, the value becomes 1.21. So therefore ripple factor for the half-wave rectifier is 1.21. Ripple factor for the half-wave rectifier. So this expression represents, it is clear that the amount of AC present in the output approximately 121% of DC value. So the half-wave rectifier is not practically applicable. So practically it is not useful. So we have to choose another option for the conversion of AC into DC. Practically, half-wave rectifier is failure. Why? Because the AC component, the AC present in the output of the output output is DC component. In the DC component, 121% of the AC value is there. How it is possible? So practically it is not possible. So that's why it is not useful for the application purpose, for the conversion of AC into DC. So we have to take another option. Then we go for the full wave rectifier. Next, efficiency. Efficiency. We have to determine the efficiency of a rectifier.